So number 21, asked by Mikhail, ball is caught in a well-padded meet if the deceleration, so you have acceleration is 2.1 times 10 to the power 4 meters per second. Time is 1.85 seconds. So you know the final velocity is 0. They're asking us for the initial velocity. So we can just simply use v1 equals v0 plus at. Now v1 is 0, v0 is what you're looking for. Acceleration is negative because it's slowing, it's a deceleration. It's in the opposite direction of the velocity. So you have the acceleration, which is 2.1 times 10 to the 4, then multiply by the second, which is 1.85 times 10 to the minus 3. So when you substitute, you should be able to get initial velocity quite easily. Number 39, asked by Georgie. In 1967, New Zealand set the record for an Indian motorcycle on the maximum speed. So V1 is 183.58 miles per hour. The one-way course was 5 miles long, so delta x is 5 miles. Acceleration rates are often described by the time it takes to reach 60 miles per hour from rest. If this time and but accelerated at this rate at 60 miles per hour from rest, if this time was 4 seconds, so it took him 4 seconds. Hold up. Yeah, so it took him 4 seconds to get to 60 miles an hour. Delta t is 4 seconds to get to v1 of 60 miles per hour. So I'm going to first leave that there. But accelerated at this rate until he reached his maximum speed. How long did it take him to complete the course? So v1 again equals v0 plus at. This helps me calculate his acceleration for up to when he reaches 60 miles per hour. So I know v1 is 60, v0 is 0, acceleration is what I want, times delta t, which is 4 seconds. This gives me an acceleration of 15 miles per hour squared. That's the acceleration that he's using to get from 0 to 60. And he said he accelerates at this rate until he reaches his maximum speed. How long does it take him to complete the course? So let's first figure out how long did it take him at this acceleration to reach maximum speed. Again, v1 equals v0 plus at. The v1 that we're using is this maximum speed, 183.58. The v0 we're using is now 60 because he gets from 60 to that maximum speed. The acceleration we have already calculated, and we're finding the time it takes him to get to maximum speed. So from this calculation you can get the time it takes him to get to maximum speed. So they tell us that the course was 5 miles long. So if the course was 5 miles long and it takes him, so you've figured out that it takes 4 seconds. Let me draw a graph here. It takes 4 seconds for him to get to 60, right? You have figured out another amount of seconds it takes him to get to his maximum speed, right? This is maximum speed. And now he continues at that maximum speed until he reaches the end of his course, right? So you can probably figure this distance out. I mean the time. You can figure this time out. or we haven't yet got here, but an approach you can use is that the area under this whole graph is equal to the distance covered. So, and what's the question here really? How long does it take him to complete the course? So if the area is equal to the distance covered, then you find the area of this shape, and that whole area is equal to 5. You solve for the t, and when you solve for the t, you can add it to the 4 seconds and these other seconds that you got here to find the time it takes him to complete the course. A simpler approach that you can use now, since we haven't yet done graphs, like we haven't studied this in detail, that's what we're kind of touching on next week, is you can figure out how much distance does it cover in the first 4 seconds. Because you have the speed, you have the time, you have the acceleration, you can figure out how much distance he covers in the first 4 seconds. You can figure out how much distance he covers in the second section, which you calculated the time for, because you'll have the time and you'll have his acceleration. You have the same acceleration, you have the time, you have the initial and final speeds. You can find out how much distance he covers in that section as well. Now, since you have this first distance and the second distance, you can subtract them from the total distance, which is 5, to figure out how much distance is left for him to cover. Now, that distance that's left for him to cover, subtract it. If you get that distance that's left for him to cover, and he's covering it at a constant maximum velocity, you can calculate the time that it takes for him to cover that distance. And when you get that time, you just simply add it to the initial times you had, the 4 seconds, the time you calculated for here, in order to get the total time that it took to cover this whole race. All right.